Hello, Precalculus. Welcome to 10-3 Day 1. We're going to move on to geometric sequences and series, and we're going to find the nth terms, and we're going to find partial sums, and before the day is over, we'll find some infinite sums. So I know what you're dying to know is what makes a sequence or series geometric versus arithmetic from lesson 10.2, or versus some of the ones from 10.1 that were nothing special at all. So the key characteristic of a geometric sequence is that there's a common ratio between consecutive terms. So every time it's going to be times 2 times 2 times 2 times negative 1/3 times negative 1/3 times negative 1/3. So multiplication is the key thing happening there. Some problems you're going to not know the ratio and you're going to need to find it. So that's our second bullet point. You can divide any term by the previous term. And this next formula is one that we would give you if we do get to do a quiz or test or final exam, or who knows, maybe just charades, something. So that we'll give you this this guy here is the explicit formula. So if you need to know the 10th term, the 25th term, that's the formula that you're going to use. And all you need to know, a sub 1 is the first term, r is the common ratio, and n is the term number. So that's the key formula, the only formula for finding all the terms. The recursive formula, we saw recursion in 10.1 and 10.2. And so again, identify the first term, and then you're going to use multiplication to get from one term to the next. I don't think we'll focus on this last bullet point, but some of you guys saw this in Geometry Honors. The terms between two non-consecutive terms are called geometric means. That's more of just a fun math fact, so don't worry about that one right now. So let's take a look. Let's see how much we can get done on a single problem right here. So step 1, it says to find the r. Now, some of the times you're going to look at it and know exactly what it is. Let's pretend that I'm not sure how I'm getting from one term to the next. I definitely see that I'm not adding the same thing every time. So possibly I'm multiplying. And so using the above, I can take any term and divide by, actually we should do it the way it's going to look on a calculator, divide by the previous term. And so then I'll realize, and if I did 50/3 divided by 10/3 or 2 50/3 divided by 50/3, I'm going to get the same thing every time. So that is the r value. So now I'm going to write a recursive formula. Don't forget there's two parts. The first one is so easy. Write down the first term. Now I need a rule to get from one term to the next. In this case, we just figured out that we're multiplying by 5 every time. So 5 times the previous term, and a sub n minus 1 is the previous term. Now our explicit formula, I'm just going to write this since it's our first time doing it. The nth term equals the first term times r, and I'm just going to practice writing that with parentheses because that's going to be what makes or breaks you on certain problems in this lesson. Raised up to the n minus 1 power. So if I do that, let's go west right here, Glenbard Green. So the first term is 2/3, and the ratio we realized is 5, and that's to the n minus 1. Let me pause just for 1 second to maybe we can add this up to the top somewhere. I don't know, let's find out. Let's make a chapter 3 connection. So how about geometric sequences and series are, ready for it, exponential. So all that chapter 3, aren't you glad you worked so hard? So geometric are exponential. Just a reminder, lesson 10.2 was arithmetic, and those were linear. So there's some key things that can help you out. All right, now we want the 10th term, so I'm going to use my rule that's in green. I guess we'll stay dark blue. So I want a sub 10, so that's first term times r to the 10 minus 1. I would just go straight to a calculator, and if you love exact numbers and fractions, you might do this answer, but based on what I've seen the last 20 years, everybody's just going to go to the calculator and do a decimal, and that would be fine. The only time it wouldn't be fine is obviously if it's a multiple choice quiz, test, or final, and we give you the fractions as your choices, but there's that guy. All right, so hopefully fun, hopefully easy. And let's take a look at number 2 before the first break. So you did a problem like this the other day, and it was arithmetic. So you were doing plus D plus D plus D, but this one is geometric, And so I'm just going to do this. I'm just going to set it up this way. First term, second term, third, fourth, and fifth. So the key thing to keep in mind here, and where students struggle every year, is they get mixed up on arithmetic versus geometric. And they try doing the same thing for all the problems, and that's not going to work, I promise. So to do this problem, we have to remember what makes it geometric. So times r gets me the next term. Times r gets me the next term, and guess what? Times r gets me the next term. And so, looking at that, I have the number 6 times r times r times r is times r cubed, and then that's equal to this term of 162. So I like the idea of writing it out the way that we did. Not mandatory, you might jump straight to the green equation, and that's fine too. And let's see what happens. So r cubed equals 162 divided by 6. Sometimes they work out beautifully. Sometimes you do get some fractions or decimals or some funky roots. But in this case, I get the cube root of, I'll write it down, what the heck. Cube root of 27, so r equals 3. Now, we're not done yet. There's more than one way we could finish the problem. Based on what we're looking at right now, I do know that my first term times 3 gets me to the second term. So what times 3 would equal 6. And so it won't take too long to figure out that the first term has to be 2. But there's lots of variations. I'll switch colors. There's lots of variations that we can put on that one. But the key thing is getting this green equation. If you get here, you're going to be good to go with whatever else we ask. If you're unable to write that equation, then nothing else is going to work out. So let's pause and then come back for page 2. See ya!